So let's start. So guys, this is another example on curvilinear and in curvilinear motion using the tangential and normal directions. So in this example, you have a motorcycle that is traveling at 1 meters per second when it is at A. So I know the velocity at A, it's 1 meters per second. And if the speed is then increased at V dot, what is V dot, guys? What do you think is V dot? It is AT because the tangential accelerator. Please, guys, don't talk. Write down your answer in the section of chat. Right, so this V dot is equal to 0.1 meters per second squared. This is the tangential acceleration because it stands for the change in the speed. I know that this tangential acceleration is 0.1, which means it's constant all over the road. It's not the tangential acceleration at A. All right, so AT is equal to V dot is equal to 0.1 meters per second squared. I need to determine its speed, which is the magnitude of this velocity, and the acceleration at t is equal to 5 seconds. So I know the time, I need to find what is the speed and the acceleration. And don't forget, guys, that I know the equation of y in terms of x. So I know the equation of this curve here. It is the equation of y in terms of x, and I need to find the speed and acceleration. How to start? I'm going to start by this fact. Since AT is equal to V dot is equal to constant, then this is what? This is an uniformly accelerated motion. And this means, guys, that I can find the velocity equation and I can find the position equation from this fact since AT is constant. So I'm going to find the velocity equation. It's AT t plus V0. Right? And since AT is constant, it is 0.1. And V0 is constant, is given, it is 1. This means, guys, that V is equal to 0.1 t plus 1. Now I can find V at t is equal to 5. It will be V is equal to 1.5 meters per second. Now, guys, I can also find S. Since this is a uniformly accelerated motion, then S will be equal to half a t squared plus V0. T plus S is 0. And since S0 is 0 because it starts from A, so this will be equal to 0. And then I'm going to have the first two terms, and this means that S will be equal to 0.05 t squared plus t. All right, guys? So this is the equation of V, and this is the equation of S. Now I can find S at t is equal to 5 seconds. And in this case, I'm going to substitute t by 5, and this will be 6.125. This is S, and of course, this is in meters. All right, but this is not the question. The question is to find also the acceleration at t is equal to 5 seconds. How can I find the acceleration? A, in fact, is equal to the radical ET squared plus AN squared. This means, guys, that A is equal. What is AT? AT is given as 0.1 squared plus AN. And I know that AN is V squared over rho. Okay. I know AT. I know V. V at t is equal to 5 is 1.5. I still have to find rho. How can I find rho? From the equation of radius of curvature. You don't have to memorize it, guys. I'm going to give it to you in your exam. In this equation, rho is equal to 1 plus dy over dx squared to the power 3 over 2 over the absolute value of d squared y of dx squared. And that's why they gave me the equation of y. What is y? Y is 0.5 x squared. And this means, guys, that dy over dx, perfect, it's x. And that d squared y over dx squared is 1. And this means, guys, that now rho will be equal to what? To 1 plus x squared to the power 3 over 2 over over 1. Okay. Now, how to find rho? I don't know x. So what is x in fact? Because if I don't know x, I cannot find rho. I cannot find an. I cannot find a. So how can I find x? Let's go back. What do I know? I know that s at t is equal to 5 is equal to 6.125. How can I relate this s to x or to y? Because in fact, I know the equation of y in terms of x. If I relate s to y, it's also could be solved because I know y is equal to 0.5 x squared. So how can I relate this s to x in order to find x so that I can know rho, so that I can know an, so that I can know a? What do you think, guys? How? You don't have the answer? Guys, I need to relate s to x and y in order to find x. How can I relate this s to x and to y? You're listening? Okay. In fact, guys, the only way to relate them is to assume that I have a differential triangle here. So I'm going to take a very small ds here, right? So a very small ds that I cannot see, but I'm going to exaggerate a little bit so that you can see. If I take a very small ds, I can assume that this curve here is a straight line because I'm taking a very small ds, all right? I cannot say that this whole s or a very huge part of s or this part, for example, is a straight line. It's not. It's a curve. But if I take a differential ds, I can assume that this is a straight line. And fortunately, the x component of this ds will be dx, and the y component of this ds will be dy. And this will be a right triangle, a straight triangle, which means, guys, I can apply Pythagoras in order to find the equation of ds in terms of dx and dy. So I'm going to exaggerate a little bit this triangle, and this will be ds, this will be dy, dx, and this will be dy, and then I'm going to assume, of course, that this is in 90 degrees. And this means, guys, that ds will be equal to what? To the radical dx squared plus dy squared. Now what I'm going to do is to take dx from this square root, because in fact, guys, what I have to find is x. I'm going to take the x from this square root. So it is dx radical. If I take the x from this radical, then this means that I have to divide by the x squared. 1 plus dy. This is not d squared y, this is dy, all right? Over dx squared. The whole ratio is squared. And what does this mean? This means, guys, that ds is equal to dx. What is dy over dx? It's x squared, it's x squared. Radical 1 plus dx, 1 plus x squared. All right? So now, guys, I can do the integration. So we're going to do this integration between 0 and s at t is equal to 5. 6.125 And now I can do the integration of this dx, radical 1 plus x squared between 0 and x to find x. Of course, guys, this radical here, radical 1 plus x squared dx, could be solved. It's difficult to solve because, in fact, this is not a regular integration. What you have to do is to replace x by tangent theta, and then dx will be 1 over cosine squared theta, and then you have to do the integration with respect to theta, and then you can replace by x, and then you can find x. I'm not going to go over it. All right, and if I give you such integration in the exam, I should give you the answer. Right? I should give you the answer of integration, but I'm not gonna give you the way to solve it. So I'm not gonna give you how to solve. You should think about this way. You should think about relating s with x and y. Alright, guys, so I'm not gonna give you the way to solve it, but I can give you the answer of this radical because it's not easy, and at the end of the day, we're not doing a math course, we are doing a dynamics course. So you can do it by yourself, or you can directly take the answer and put it here to find x. So whenever, guys, I find x, I can find rho, I can find a, and I can find a. So I think x will be 3.184. So you have, of course, to replace this, to substitute this x here. So you know rho now. Whenever you know rho, you know an. Whenever you know an, you know a. So that's it. Okay, any question on this problem? Quickly, guys, any question on this problem? No. All right. So let's do example 13 now. Oh, we should get direction. Yes, you're right. We should get direction because they are saying determine the acceleration. We should get direction. You're right. So how to get the direction? In fact, if you go back here and no, this is not the problem. All right. If you go back here and you know that this will be at, let's say this is at is equal to 5 seconds. So this will be at, let's say, and this will be an. All right. Then you have to indicate like an angle, right? So let's say this is A. So you can indicate an angle, and then you can do tangent alpha. And by the way, you can also find the angle between this AT and x-axis, because in fact this angle is the derivative of this equation. Okay, so you can find also this angle, right? Because I know the equation. And then whenever you know this angle between A and AT, so I know the angle between A and AT. All right? And I know the angle between AT and X. I can sum them together in order to find the angle between A and X, right? So whenever you know the angle between A and X, you can directly know the direction, because in fact, this angle here will be with the constant direction, which is I. Okay?